So let me just go ahead and oh, and great, it's slightly off the screen. Well, blurred. Oh, yeah, that's a good idea. There we go. Let me try that again then. And just there we go. I think it's working. There we go. All right. So I'm going to talk today about color 3D printing with Python. And really what this is about, oh, hey, I decided to, maybe? All right. I'm going to say that's good. This is a note to everyone else who's speaking, try to not do what I did and get there a little bit early. So I'm going to talk about color 3D printing with Python. And really what this is about is a chance to talk about some kind of GWiz stuff. I work for Chevron. This is what I do in my spare time. Actually, what I want to talk about for the moment is puppies. Everybody likes puppies, right? This is Darlin. She's a coonhound. She does lots of cute things and derpy things. And really what I'm getting at is you can actually 3D print your dog now. I'm not really plugging these sites particularly, but they're places that will custom model your dog. So the question kind of came up is if we can 3D print our pets, why can't we 3D print our data? So why can't we 3D print geology? That was really kind of where this got started. And some people already are. There's several folks in academics playing around with things. I've seen at a few vendor conferences, I've seen reservoir models 3D printed. GeoFab Lab, I think they're in Iowa, Indiana, I don't remember exactly, I'm going to forget, but they have a 3D printer and doing some interesting things with 3D scans of fossils and topography and other things. Quick shout out to Brendan Sullivan, who's a friend of mine. This is really his idea and kind of his question that got me started on this, so I just want to kind of point out that this is largely him asking this question and us thinking about it. But one of the things with 3D printing stuff, really it's easy to come off as gimmicky. So we don't just want to 3D print it because, hey, 3D printing is neat, and we can 3D print our dog, we're going to 3D print geology. It needs to be useful. So how do we avoid those gimmicks? How do we make it something that's really quite useful? And the big thing is that form isn't enough for geoscience. You think about 3D printing, what you're seeing usually is a single color, printed little plastic thing. It's great if you need a tool or a cover for something. It's very useful then. But for geoscience, we need to show our data. The form is not all of the data. We're usually putting something on top of that form. So color is really crucial for 3D printing for geology. And color 3D printing's come a long ways in the past couple of years, so now it's pretty easy to do. You can ship things off to Shapeways or iMaterialize. There's a lot of services that the printers are expensive, but I can have a single print made quite cheaply. So the technology's there now. It wasn't a year and a half ago, 2 years ago, but it is now. And it really makes a big difference in what we can do. But the biggest thing is we need to find the right niche. Just a little side note on this. I used to do a lot with stereo 3D visualization back in grad school. And one of the things that, again, it comes off as gimmicky. We bring people in, they look at it, it's, oh, gee whiz, it's cool, but we never used it for much until we found the right thing to use it for. And that was, strangely enough, volumetric visualizations with very smooth gradients. In this case, it was tomography data. A lot of things that you make an isosurface out of it, and okay, that's great, but you're not really seeing much. When you could really play around with the transparency and do good volume rendering, suddenly that stereo visualization just became incredibly useful because the volume rendering is hard to see otherwise. You volume render something and put stereo visualization on it, it's great. So that was the niche for the stereo visualization that everyone said was a gimmick. I think for 3D printing, it's really that it's a communication tool, not a visualization tool, at least for the geologic data. I'm not talking about in general, but the key thing is not to try to make a better visualization out of it. It's not for you. It's for your audience. So what I mean by that, let me just go ahead and run this really quick. Should pop up pretty quickly here. Well, that's interesting. Well, anyway, what we have on a workstation, we can visualize things in ways that we can never do with a 3D print. So for example here, when this decides to finally launch. I thought that should have been displaying full screen already. Just to give you some quick idea here, we can take and slice and dice this in all kinds of crazy ways. We can move through it. You can get a lot more out of a visualization like this than you can from a 3D print because it doesn't have to physically exist. But the difference is I'm driving this. I'm getting a lot out of it. I'm asking questions and answering them. You guys in the audience are just passively watching. So that's really one of the big differences that 3D printing allows, is that basically it's a communication tool, not a visualization tool. What I mean by that is you're driving the interaction. So if you have a non-technical audience, they get to ask their own questions. They get to interact with it. In a lot of ways, physical is the original interactive. You have something you can hold, you can touch, you can move around and look at. So it's a great way to communicate to a non-expert audience. And in my mind, that's really the niche for 3D printed visualizations, at least in the geoscience, is really trying to get it across to people who aren't geoscientists. Even people who are engineers. I mean, a lot of times we deal with complex subsurface data, and trying to communicate that, in a lot of cases, gets lost, and physical, tangible objects can actually really help that. I don't have anything to back that up, but that's just my opinion on it. All right, so this talk is supposed to be about doing it in Python. So MayaV and MLab, traded VTK, really makes this actually quite nice. So I'm going to be showing a lot of examples for this. I'm going to walk through one example in a lot of detail and just kind of skim over the other fancier ones. They build on the same idea. So just to let you know what's about to happen here. VTK is really great for visualizing your 3D data sets. And MayaV, MLab can make it really simple to call things from Python, get the basic building blocks set up. And VRML, interestingly enough, is actually the de facto standard for color 3D printing. STL, other formats that are commonly used for 3D printing, don't actually support color. So VRML is kind of ancient and outdated in some ways, but it does what it's meant to do quite well, and it happens to support full textures and full color. So it's actually what's used in most cases. VTK makes it quite easy to save a scene as VRML. That's the basic idea. We can create the visualization. We can save it as VRML or X3D, which is the XML equivalent, and basically send it off to a printing vendor, and a couple weeks later you get back a physical print. Big caveat here. VTK is a visualization environment. It does not check for or look at printability. So you really need to verify that what you're going to do can print. One of the things I was going to do initially was print out a bunch of copies of the MayaV logo. So this is a quick example, basically that it's online. It's one of the MayaV examples. I'm just going to go ahead and run it. It's a good example of something that you actually can't 3D print. So it wraps around in on itself. It's a buoy surface. It's kind of like a ball. I don't know how it's pronounced, but it's kind of like a Klein bottle. It flips around inside out and intersects itself in multiple places, and also it goes to 0 thickness along each of those edges. So this is the sort of thing that makes a great visualization, and you can't 3D print in the way that VTK makes the mesh. You could take and edit it and split it in different pieces and do all that, but VTK is a visualization environment. It doesn't have a lot of those tools. So it's up to you to think about the visualization you're making and think about, can this exist? But if you get around that, VTK is a great way to take your data and make a printable visualization. Just something to keep in mind. All right, so we're going to go on here. I'm going to start walking through an example of building a printable model out of some topography. So the end result, like I said, I was going to pass these around. Maybe I should just go ahead and, you know what, I'm going to do that. We have time. I want these back. Start with that. So I've got one of them going around. I partly do that because I've got 2 of these models. But we're going to build up kind of what you need to build the model that's going around the room right now. So to start out with, we have elevation. It's actually is a geotiff, so I'm going to use GDAL to read it in. And then I'm going to display it with MayaV's MLab environment, which is a simplified kind of interface around it. Okay, so we're just displaying the surface here. Yay! All right, 3D surface, topography. All I did was pull it in, called mlab.surf, and that's basically it. Now, one of the things, whoops, I ran it twice. One of the things that we didn't do there was worry about kind of real world space. That was not at 1-to-1 true vertical exaggeration. So let's worry about that really quick. Like I said, that's a geotiff. It actually has real coordinates with it. So let's read it in and properly come up with the X and Y coordinates. And then we'll use, instead of surf, we'll use mesh, which will handle full general XYD. It's basically the same sort of thing. But we'll put in the XYZ, do everything else exactly the same, and it'll look much flatter this time. This is true 1-to-1. Now, this is actually one of the more mountainous areas around. This is Glacier Bay in Alaska. That's like a 2-kilometer high peak right there, and that's sea level. So this is actually a very rugged area. Just 1-to-1 kind of de-exaggerates things. We look at it from afar. If you're sitting down here, it looks a lot more rugged, just how it goes. Anyway, we'll come back to that in a second. We've now got real world coordinates. Sorry about that. Let's make it something we could actually print. So what we've got here is, again, this XYZ. We're going to add in basically a bottom so that we get a nice little box around it when it decides to display here. So what you'll see is we have the same surface, and we've just put a box on the bottom. At this point, you could print it. Now, there's some caveats here. I haven't worried about scaling. We're going to cover that in a second. It's actually pretty big, but this is all you need. You need something that kind of physically holds together. So just to go over what I did there, I just used numpy.pad. It's a quick way to just kind of take things, and I wrapped up the edges. So I just made the edges come up to the surface. Very simple idea, and we'll kind of use that for everything else. I mentioned that the scale's not right, just to give you some sense of that. That's in meters. So you notice the units here, if you can see them, are something like, we've put 0 there, but still that's like 2.7 e to the 4th. That's, that's large. So if that's millimeters or inches, which is usually what these models are assumed to be in, you're not really going to be able to print that. So we need to shrink things. VTK gives us a pretty simple way to do that. With TVTK and MIV, we have to kind of call down just a little bit further. But all we're doing is we're taking the actors, these are what you see in VTK, and we're applying a scale to them. So I'm going to shrink it by a factor of 1,000, 10,000 actually. And it's going to look exactly the same. Oops, I forgot to reset the camera. We'll get out of that one. We'll come back to it in a second. Basically, it looks exactly the same, it's just smaller. And we can also add vertical exaggeration this way. So in this case, I've scaled it down, but I've also expanded it in one axis. And so you'll see what will happen here in a second. So now we've got the same thing. It's actually shrunk down to a size we could print, but we've also stretched the z-axis by a factor of 2.5. Makes it look a little bit better. So same basic idea. What we really want to do, though, is put something on that surface. Like I said, we want to do something with the colors more than just display elevation. So this is a superficial geology map. It happens to be clipped to exactly the same area, which makes it a bit easier to use. In 3D modeling terms, it's a texture. So we're going to texture map that surface. We have to jump through a couple hoops here, just giving you some idea what it would look like. But all we're doing is we're basically saying, okay, take this thing we just plotted and use this image as a texture. And indeed, what we get is eventually basically the model that went around the room. That's it. So, that's a 3D printable model that actually looks kind of cool. But we've got these blank sides. It'd be nice to do something more with them. So I'm going to give you, just to show you, the quick people who can't see the 3D model. That's a picture of it. I'm going to hold up another version here so everyone can kind of maybe see it that hasn't gotten it yet. It works pretty well. Oh yeah, one caveat I forgot to mention. There actually is a quirk with printing these, and that's that some formats don't like the embedded textures. So I did write a little thing to unembed the textures that'll be distributed with this notebook. Don't want to go through and explain it all, but basically you need to take things out and put them back as simple pings that it links to, because the Shapeways doesn't like the VRML that has embedded textures. iMaterialize is happy with it, but just format thing. So there's one little other thing you have to do before you print it. Okay. Let's add some textures on the sides. So to do this, we need to build the sides individually. Before, we just built them as one big thing. So all this does is it goes through, takes a slice along each edge, and then basically makes a vertical wall out of it, and then applies a texture on that vertical wall. I won't actually run that. We'll just go on to the next part. And then we can add textures on each of those walls. And now it's actually going to run a full script down here at the bottom. But basically what we'll get, these are pre-prepared textures. I hand-labeled things. These are made mostly with Matplotlib, and then I actually hand-placed some of the annotations in Inkscape because I wasn't quite sure where they should go to point the right things. But that's basically a nice textured side model. So I'm going to go ahead and just show you what this would look like from a picture, and here's the real thing. Same deal. So again, you can apply this. Now, let's say we had seismic data. We do this a lot with kind of the topographic data I just showed. We can do the same thing with seismic data. With seismic data, we actually have data in that vertical direction. So we have a 3D seismic volume. We can take it and we can put seismic on the sides. So here's the exact same idea. And I've just got a couple of these to show. Well, that's just pointing out we can see seismic data. It's a 3D cube. Let me go ahead and just go on to the... So if we take and put this on the sides, same general idea, we get a model, something like this. Now, I've made it hollow just to save a little bit of printed material, but you see the idea? That's this guy. There's a picture of it. We can even make a top of that and use it so that we can split things in half. Show this really quick. So here's a top. And this actually nests in. So this is the top, so everybody can see it. This actually nests in so that you can take them apart. The basic idea here, you can kind of pull this apart and kind of look at it in multiple pieces. So that's kind of the basic idea. You can play with this in a lot of different ways. You can put geologic cross-sections on the side. But the main point here is that we can use 3D printing for more than just gimmicks. We can actually use it as a communication technique. If you need to get something across to a non-technical audience, handing someone something like this gets them to think about it and interact with it in ways that passively watching a visualization doesn't. It's never going to replace what we can do on a workstation, but it's a good complement to it. And so really we also need color for this. The form is not enough. Again, this is color 3D printing is what really makes this work for geoscience. We need to put other information on top of our data. But finally, the scientific Python ecosystem kind of gives us the tools we need to do it, and I think it's kind of nifty. So that's basically my talk. Be happy to take any questions.